Let's take a look at these circuits. This time we're supposed to find the current in each of them. Of course, we're going to use Ohm's law. Ohm's law says current is equal voltage over resistance. In this case, I'm going to have I1 equals V1 over R1. Again, let me remind you, write the formula first, always. Next, enter the values of your voltage. We have 3 volts, and always put units, and 1 ohm. 3 volts divided by 1 ohm gives me 3 amps. Voltage divided by ohm is equal amp. This is the current in this circuit. Remember, we are going to use the conventional current flow, so I'm going to say that current flows from positive terminal to the negative. Remember, the longer bar stands for positive terminal and the shorter one is negative one. So this is the answer to this problem. Let's take a look at this one. In this case, I have to find current again, but because I have V2 and R2, I'm going to call this current I2. I2 is equal V2 over R2, which is equal 12 volts over 3 kilo ohms. This is equal 4 milliamps. Again, many students make mistake. Why? Because they don't respect the powers of 10. K represents the power of 10, 10 to the third power. Remember, anytime you see prefix, you have to use the proper keys on your calculator. Simply type 12 divided by 3 exp, if you have this button, or double E button, and we said kilo represents 10 to the third, you have to press exp 3, and after that press equal. You are going to see answer like 4 times 10 to negative 3, or you are going to see something like this, 4e negative 3. It means that we got 4 milli. And because we are looking for current, we're supposed to add amps. This one also stands for 4 milli. So 4 milliamps is the value of the current in this circuit. Let's take a look at this example. We have I3 equals V3 over R3. Formula first. I3 equals V3 50 volts over 2 mega ohms. I3 is equal 25 micro amps. Again, please make sure that you are going to enter power of 10. 10 to the 6, because mega represents 10 to the 6. And if you are going to enter the values of voltage and resistance properly into your calculator, you're supposed to get this answer. This is the solution to this problem.